Hey guys, Professor Jacobson here again. Today we're talking about Chapter 34 this week, our emission control, diagnosis, and service. We talk about our onboard diagnostics 2 testing. Many states are using the onboard diagnostic 2 monitors as a part of their mandatory emissions inspections. We talked about our inspection and maintenance different programs. This just happens to be one of the things that we are seeing used because it's an easy indication of whether there is problems with that vehicle or not. What we can do is be able to check that malfunction indicator lamp operation, be able to command it on and off, maybe check for our diagnostic trouble codes, and check those monitor statuses. Make sure that EVAP monitor is passed, make sure that Catalyst monitor is passed, make sure any emission monitor period has passed. If they have not passed, in a lot of cases we may see a diagnostic trouble code indicating a part that is wrong with this vehicle. Our exhaust analyzers, we've talked briefly about our exhaust analyzers, and what we're talking with those is using a sample out of that to be able to see what's going on with the engine. Now the way we're able to do this is the exhaust analyzer is going to use a sample from a hose that is connected into the exhaust. We can have two different ways. We can have either a 4-gas or a 5-gas analyzer. Our 4-gas analyzer measures our hydrocarbons, our carbon monoxide, carbon dioxide, and oxygen content. We add the addition to our NOx gas for our 5-gas analyzer. So we have our oxides of nitrogen for our 5-gas analyzer. Limits are set by vehicle year, model, and local and state laws when we are using the exhaust analyzer for our emissions testing. Our onboard diagnostic 2 monitors. Each requires one or more diagnostic tests. They may be continuous or non-continuous monitors, and only when a certain enabling criteria is met. So maybe it's a drive cycle, maybe it's just a warm-up cycle, maybe it's a thermostat code. So we have something, our thermostat monitor, where we have to have the vehicle be very cold and actually start from a cold state and reach all the way up to X amount of coolant temperature. So there's different criteria that needs to be met for each one of these. If a system or a component fails, a diagnostic trouble code is stored and the malfunction indicator lamp is on within 2 drive cycles. Pending diagnostic trouble code is stored when a concern is initially detected. From there, it can move up to a full diagnostic trouble code where it would reach into our history or our current codes. Still speaking about our monitors here, many inspection maintenance programs mandate checking those monitors like we'd said before. A diagnostic trouble code may prevent the monitor from running. So if we have a EVAP code, we may not even get the monitor to run for this vehicle. Or we may not be able to do that with maybe a heated oxygen sensor monitor. And as we talked about, if we have our heated oxygen sensor monitors, those must run before a catalyst monitor may run. So if we have a problem with an oxygen sensor, we may be faulting out on two tests that this onboard diagnostic 2 monitor can run. If there is no diagnostic trouble code present, but the monitor is incomplete, the vehicle should be operated as recommended to enable that monitor. So we should do whatever we need to get that monitor to its status to where it can start trying to find out and sample and make sure that it is running properly, make sure the vehicle is running properly. Our evaporative emission control system diagnosis and service, what we talked about. If gasoline odor is present, check the EVAP system. It's one of the quickest things we can do is be able to check out the EVAP system. Fuel or fuel vapor leaks should be repaired immediately. We do know that they're flammable, and on top of that, it is a emissions concern that we must take care of. With that, a lot of times we think we have a problem. We can check the EVAP monitor status. We will most likely find if we are smelling gasoline or just some sort of fuel vapor present, we're going to notice that possibly that EVAP monitor has not been completed, or it will simply say incomplete. When we go into that now, we can find out why is it incomplete, and is maybe there a leak in the system. We need to get out maybe our smoke machine and be able to smoke it and see if there's a leak, or if there's maybe a purge or vent solenoid that's stuck open, closed, something of that sort right there. Our EVAP monitors, a leak can generate multiple diagnostic trouble codes. All EVAP diagnostic trouble codes require 2 trips, so we're going to have 2 trips in this vehicle to be able to get that diagnostic trouble code to be set. Our vapor purge is monitored by the pressure sensors. We talked about those pressure sensors. They're very, very similar to our manifold absolute pressure sensors, where we would have a 3-wire sensor we would have a 5-volt reference in, a ground, and then our center wire would be our signal wire, and that would vary accordingly to our 0.5 to our 4.5 flow rate, and then on top of that we would have that 0.5 volt problematic on the top and 0.5 volt problematic on the bottom. Our newer systems, such as our enhanced EVAP systems, do have a monitor flow rate, and they do detect very, very small leaks, as we had talked about also. A system purging at idle. So we got a couple things here with our system. If it is purging at idle, we can have rough idle situations. So we cannot have it purging at an idle. It needs to be at an actual engine RPM moving up state. We need to have that RPM above. So if we're doing any testing with that, we need to be able to move the RPM up into maybe that 1500, 2000 RPM range. Or if we do not, we might have a stalling problem with that vehicle in our shop when we're working on it. We can look for cracks in the hose of the canister. If we do have cracks in the hose or canister, we can have gasoline odors around the vehicle, and obviously with that we may just find some simple trouble codes in the system also. And very, very commonly is that loose fuel filler cap. We're going to see trouble codes with that, and maybe a gas or vapor smell, a fuel vapor smell around this vehicle. If we do have that code, it's not as simple as just putting a little grease around that ring. We need to be able to actually look at and test that cap, and if it is a cracked O-ring around that, we need to be putting a new cap onto that. We talked about our smoke testing. Nearly all of the OEMs are recommending this method now. The leak is identified by the escaping smoke out of the system, so we would be able to tap into our EVAP port and put pressurized smoke into the system, and we would be able to see if there's anything leaking. With that being said, we can also test the vent solenoids and the purge solenoids to make sure they are operating properly also. We can use our scan tool to be able to turn on and off each of those solenoids to see if they are able to flow properly. The solenoid may be closed through the scan tool to commands, so we need to be able to go in with maybe our Modus or our Verus, any bidirectional scan tool that we can have, and be able to control them closed to make sure we're having a sealed system, and then on top of that open them up to be able to see if they are working properly. Consequences of maybe problems with PCV systems. PCV valve that is stuck open may cause a lean air-fuel mixture. So if you guys see something that we're having problems with fuel trims, in that case we may be having something as easy as a stuck open PCV valve. We may have rough idle problems, and that can obviously be caused with our stuck open PCV valve. We could have stalling problems with this. Our PCV valve stuck closed can cause oil in the air cleaner. We could have moisture or sludge in the oil, and we could also have oil leaks with that too. Now, the reason we would be seeing those oil leaks is because of that very, very high pressure in that crankcase. Like we've said multiple times, visual inspections, we can find so much from the simple visual inspections. We could maybe, if we think we have a PCV valve that's having a problem, we can look right around that PCV valve, make sure we can take it off, we can shake it, make sure it's actually moving up and down, the ball inside is moving, make sure it's in there, make sure it's not broken, make sure this hose is connected up to it. So simple visual inspections that we can find with this. Functional checks of the PCV system, like I said, check for vacuum to the valve itself, shake the valve, listen for it to rattle. Some manufacturers recommend checking for airflow through the valve itself, go off the manufacturer's specifications for that. Pinch off vacuum hose to the valve and listen for it to click. If it does not click, it may be stuck. Now, we don't know if it's stuck necessarily open or closed in this case, but we can find that out as simple as, does it have vacuum to it through it? And then if it does have vacuum through it, it would be stuck open. If it does not have vacuum through it, it would be stuck closed. We could, with our gas analyzers, measure the carbon out of this, so we can look at our CO, and we can look at our oxygen out of this, and we would look at the readings with the valve in and out on this also. Our EGR system, our EGR valves are calibrated for each engine. Performance can be affected with too much or too little EGR flow, and we do have a list of different things here for you on that also. EGR system condition symptoms. If we have an EGR valve that is stuck open, we can have rough idles. If we have something that's such as a no start, surging, or stalling, maybe it is stuck wide open, or if we give it a lot of throttle, maybe we can get it started up. It could be as simple as an EGR valve being stuck open. If it is something that is vacuum operated, we could check the vacuum to it. If it's electronically operated, we could be able to try to control it up and down and or remove that and watch and command it with our bidirectional scan tool once again to see if it is either opening and or closing with that. Our EGR stuck closed or system inoperative, so we can see something also with poor flow on this. If we have something with either it's stuck closed or very, very poor flow, we can have detonation or spark knock. We can see our excessive oxides of nitrogen or NOx gases or NOx emissions, and we can have poor fuel economy with this also. Our scan tools, EGR is monitored. EGR monitor is activated by input from the engine coolant temperature sensor, our intake air temp, our throttle position, and our crank position sensors. We do have our DPFE and our vacuum regulated circuits, and we are checking those for opens and shorts. We need to be able to look at different hoses with the scan tool, and they are checked once per drive cycle. So we are checking those. The computer is checking those all through that to make sure that there is no leaks in the system. And once again, that's going to go back to that sensor being able to look at the pressure that is inside of some of these in your linear flow rates of the EGR. Malfunction indicator lamp is on if it fails 2 tests in a consecutive drive cycles. Too much EGR flow on map systems will increase manifold pressure. If we have excessive EGR flow, we will cause negative fuel trims also. Too little EGR flow will cause positive fuel trims, as I had mentioned with the fuel trim possibilities in an earlier slide here. Check engine, mechanical condition, and fuel, and your ignition systems if you guys are doing any EGR system. Sticking valves, obstructions, loss of vacuum. And we need to be able to look at each one of these little pieces. Now the obstructions is one thing that we had talked about. The obstructions, we may not be able to see that without removing the actual EGR valve itself. We've talked about some of these where maybe some condensation mixing up with the carbon that's actually flowing through this, we can create a gummed up kind of instance in some of these intake manifolds. So it might not be an EGR fault for that insufficient flow problem. It may be it's just gummed up all the way through the manifold or all the way through the head where the EGR should be flowing. We need to check for vacuum hoses. We're looking at those for leaks, kinks, cracks, and some flexibility. We talked about our catalytic converters last week quite a bit in the week prior. We're getting into this now where we're seeing stuff where we're actually looking at our sweeps up and down. If we're looking at this on our scan tool and I see my post-oxygen sensor the same as my pre-oxygen sensor, we are seeing a problem. Our pre-oxygen sensors should be moving up and down. We should be seeing that 0 to 1 volt sweep or that 100 millivolt to 900 millivolt sweep, either way, one of those ranges. Now, also with that, we should see that post-oxygen sensor staying very, very steady. If it is not staying steady, unlike this one here, see if we see this, we may have a bad catalytic converter. If it is staying steady, we may be showing a good catalytic converter. Now, there are different ways to test this. We could do some temperature testing. If we have something that we think is maybe plugged up, we could simply look at that and see if it is very, very, very hot on the engine side of that catalytic converter and maybe colder on that exhaust or that tailpipe side of that catalytic converter. It's telling us that it's getting very, very hot and it's a blockage. We can simply use our infrared temperature sensors to tell us that. And that gives us a simple indication. It does not tell us exactly what's wrong. There is further diagnostics with that. But it just does give us a simple indication that, hey, there may be something going on in that. With that, if we do have that kind of problem, we might have some sort of restriction of flow. If we do have restriction of flow, it's an easy way right there of indication is looking at that temperature testing that we're going to be able to have. I showed you the guy's picture last week, and we've talked about it more and more. And it's simply something as easy as I just talked about, which would be our good catalyst up here, versus what we would see something. It is a pre-oxygen sensor moving up and down, like it said, in that 0 to 1 volt range. And we have our post-oxygen sensor staying very, very steady for what it is. When they start to match, we start to see that there's going to be problems with that. Converter diagnostic trouble code does not always mean that the converter is faulty itself. A small leak in the secondary air system could be a problem, maybe a misfire, or maybe an exhaust leak in the system. That's all we got for you guys this week. I hope you guys have a good night. I hope you guys do great on your test, and we will talk to you shortly. Thanks, guys.